Good morning, everyone. Can you hear me?
Good morning, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So we have another paper that is radar engineering. So let us have a start of that one. Okay. So actually, radar is the very high-end micro device. So for that things there are several books, but basically the book of Skolnick that is treated as a mother book. So mainly I will follow the book of Skolnick. Except these four books, there are many other books are there. So you can consider any book. Okay, no problem is there, no issues is there that I have you have to consider only the book of these four or like this one. So, if I just have an introduction that what is radar, how does this abbreviation generated? So, the generation of this thing is radio wave detection and ranging. That means if we break up this whole term, radar, RADAR, the full term is the abbreviation which is coming from radio wave detection and ranging. Okay. So as such, if I see, then it is nothing but an electromagnetic systems by which actually the electromagnetic wave is transmitted towards some destinations or towards some locations or the kind of things. And whatever the objects, those are present in the background, based to on that object, based to those objects, there is a corresponding reflection. Okay, that thing is again received by the transmitter locations or the transmitter positions, and then we can extract an informations. So what is the basic or the schematic mechanism? Fast electromagnetic wave is transmitted. Okay, so when a electromagnetic wave will be transmitted, it has a certain directivity. So what happens? The wave propagates and it penetrates, or rather it intercepts the whole background. Suppose you can ask me that if I transmit a wave from the Bardhaman, then how far it will be able to penetrate or how far it will be able to go. Basically, that depends on that what is the power of the wave you are considering, at what gap, that means at what pulse repetition frequency. Usually that is given with an abbreviation like that, PRF, which is a very important factor for the operations of the radar. So at what gap the energies are pulsating or energies are generated in form of pulse. So based on that, we can have an expected range. Suppose at these locations, whatever the energy that is transmitted towards some background or towards some destination, suppose the wave is transmitted towards the eastward directions, horizontally eastward direction, energy is transmitted, then what will happen? Based on the energy of the wave, because you know that with the increase of distance, the energy of the wave decreases. So based on these things, what happens? It will interact with the background. Suppose if it interacts with the background, in the background there is, suppose a pond is there, field is there, field of vegetation is there, some buildings are there. So suppose this is the normal feature of the background towards which we have transmitted the energy. Then what will happen? There will be interaction with all the members of the background, fixed members of the background. So what are the fixed member? This water body is there. Suppose we are indicating with W, this water body is there. This green field is there. So it will also interact with the green field. So that means the energy of the electromagnetic wave that will be intercepted by this green field. Then some buildings are there. So it will be also intercepted with the buildings. Then what will happen? Based on the nature of the interception, that means the interactions with the incident energy and these individuals, there will be a corresponding reflections. Okay, but the amount of reflected energy will not be same, because what is the amount of reflection by the water or the ripples, that will not be same that what will be the reflection from a civil architecture or the civil buildings, that will not be same what we have from the green field or the ground what we are having. So that means suppose some trees are also there in between these places or in between these demarcations, then we are getting the different kinds of the reflected amount of energy. Some deflection is coming from water surface, some is coming from these green field, some are from the trees, some are from the buildings. So nature of the material because building is made of some material, water have a different material. Nature of the materials what we are using there, or what is the consistency of that particular constructions, we are getting the different kind of reflected energy. And when this reflected energy, that if we are able to receive by our transmitted locations, then what are the conditions? The condition is input energy is available to us, because we know at what frequency, at what carrier frequency, at whatever I mean the parameters we have transmitted the energy, and all these different reflected components, they are also available to us. So just if we compare these two components, that means the transmitted energy and the individual reflected energy from all these bodies, then we will be able to justify that what kind of materials or what kind of sources are there who have produced this reflection. Not only this, we will also be able to find that what are their locations. Okay, so actually this finding is found in terms of radar, because its basic form is what? Radio wave detection and ranging. Clear? So to do these things, actually several lots of electronic processing and the systems are there by which we can systematically transmit this wave and systematically also collect the reflected energy. Now a very big question is there, that what we will do with this one. If we know that at a distance of 2 kilometers there is the civil locations, at a distance of 1.5 kilometers a pond is there, at a distance of 2 kilometers a green field is there, then what is the necessity to find these repetitive things, that there is a pond, there is a things. Actually the role of this thing is, when we consider this radio wave detection and ranging, actually the main objective of this thing is to identify any unknown object, or to identify any intruder in this background. Because just right now, if we consider, suppose we are in a classroom and towards the hostel building we are transmitting the energy, then we know that towards the hostel building, when we are transmitting the energy, there are two boys hostel, one girls hostel, green field is there, some water body is there, I mean the green trees are there, all these are known picture. So these known pictures, that means who are fixed in the background, towards which we are trying to ranging, or we are trying to identify any intruder. So all these are known actually as the clutter. That means who are permanently present in the background, or who are not our point of concern, that is actually known as the clutter. What is our objective of for this radio wave detection and ranging? Our objective is, if some any intruder are there inside this background or over this background, then we have to identify that intruder, whether that is a bird, or some man is entering into there, some group of animals is entering into there, or some flying aircraft is entering into the background of the picture. So with the help of radar, actually our objective is to identify that extra object. Clear? Sometimes this may happen that the total, I mean the ambience, that becomes very windy. So if it becomes very windy, then what will happen? There will be a slight movement of the leaves of the trees or the kind of things. So if I denote that that is an intruder, that some changes are there, some different kind of reflections are there. Because if a fixed tree is there, then whatever the reflection will generate from the fixed tree, if it is a windy tree or the windy environment is there, then what will happen? The leaves will move, the strings will move, so there will be a different kind of movement. So from there, if we collect the reflected amount of energy, we will get something difference of the picturing what we have in the earlier case. So that will not be treated as the intruder, because that is not a change, that change is there because of the ambience changes, because of the environmental changes. So we have to consider that into the clutter. Okay, so that means that is the movement of the clutter, that things. Suppose some heavy wind is there, then what will happen? The water surface, big ripples will be there, big ripples will be there. So the reflection from the water surface in the still condition, that will not be the same in the windy conditions. but that also not indicating any existence of any unknown object or existence of any intruder. So we have to also exclude that information because that is the clutter movement itself. Okay, so if we are able to include conclude about that those things, that this is about the clutter, this is about the movement of the clutter, then rest of the changes over your reflected energy, that will indicate some existence, extra existence. This extra is existence is the conclusions of your radars. Okay, so if your display system, if we are able to plot all those things, then we can get a kind of variations like this with the time. This is suppose time, and this is suppose about the signal power or the extracted power after the processing of the signals, reflected signals. So suppose there are these are the different levels. This is your RMS noise power level. This is your threshold level, and we are suppose getting an ultimate exclusions like this. Okay, so then what does this mean? This whole means that whatever the graphics or whatever the process, whatever the excursion of the signals over your display system. Look here, the margins what we are using here. One is the RMS root mean square noise fall level, another is a threshold level. So somehow, if your signal, processed signal, which is driving the display unit or the kind of these things, if it exceeds the threshold voltage, so that means the thing is the received energy, processed energy, that is carrying clutter plus some extra. So this extra means that there are some extra objects. So this indicates some extra energy is there. So at these positions that where it exceeds this level, so this indicates that some alarming, obviously this will drive some alarm system. So from there we can get an indications both on display and by the hearing alarm that it is exceeding the VT level. So that means it is indicating some extra existence is there. Now the thing is we have to identify that what kind of extra existence is there, whether it is movement of the clutter or it is movement of the entrance of some human being or some flying bird or some aircraft, different. Because the interceptions of the electromagnetic energy with human skin, that is different. If it is interacted with the flying birds, because bird's body is covered with feather, its reflection coefficient will be different from the human body. If it interacts with some flying aircraft which is entering into this picture or entering into this background, then the interaction will be with the materials of the aircraft, so that reflection coefficient will be something different. So when really some extra object is there, based on the material of the object, the existence of the reflection coefficient which will be carried over this clutter, that will be something different, and it will be able to create some extra indications whatever we are getting this. But always this excess of VT level will not be able to give us the correct decisions. We need the repetitive observations or the repetitive reading, because sometimes this may happen that because of the movement of the clutter it exceeds the level. Sometimes this may happen, suppose at this position or this position, the value of the reflection coefficient from the real object that becomes so less that it is unable to give some existence of the extra things. Okay, so there it may happen covered by the noise energy or the clutter waveform, and it remains under the level of the VT. So in that condition, we are unable to detect the things only with one observations or one reading. So for every cases, we need the multiple times of observations or the multiple times of readings, so that we can come to a particular conclusions by which we can identify that some object is appearing in the background or in this case. Okay, so now this is not only the conclusions that what we are trying to achieve from here. The first conclusions what we are obtaining from here, that thing is uh, number one is distance. Number two is location. Location means angular positions. Okay, so that also we can find from the radar. It just if we use a proper beam width, that means proper antenna beam width, then by shifting the antenna beams, suppose the direction is obtained from the ranging equations. Later I will show you that we can how we can measure the range or the distance. Actually, in the abbreviation, range means the distance, horizontal distance between the positions. So, or it may be the vertical distance. So whatever the distance we are considering here for the range, abbreviation for the range. Now the thing is location. Location means the angular position. That means what will be the elevation and the azimuth. If we are able to find this three-dimensional coordinate into the space, that means r, theta, phi, then we are able to find its total locations. Okay. Sometimes this is also very much essential for the tracking. So let us see that how we can find the location. To find the location, if we use a scanning antenna beam or a antenna beam which is operated in different directions, like this. Suppose it is operated in this direction, then in direction, then in directions, making fix the range operations. Then, based on the locations, that means where the object is there, we are getting maximum interception in these directions. Suppose if we consider the beam direction in this direction, then the distance from this object and to this one is not matching very accurately. If we consider for this third position, let us indicate this first position, second position, third position. With respect to the third position, also the interception is there, but it is not in a very accurate positions. But if we consider the second position, just with respect to this object, then what we are getting, we are getting the maximum interception. So maximum amount of energy will be intercepted by this object. So the amount of reflection what this object will generate, that will also be maximum. So just by considering the antenna beam reflection, or by just comparing the antenna beam reflection coefficient among these three positions, first position, second position, and third position, we will get maximum amplitude for the second positions. So by considering or by comparing the maximum amplitudes, maximum amplitudes, we can obtain the location informations. Okay. So range we can find, location also we can find. Another very important thing, that whether the object is a moving object or a fixed object. Okay, identification of this one. This one is also possible. Already you know with the help of the Doppler. How it happens? Because you know that if the there is a relative velocity between the transmitter and the receiver, then shift in the receive frequency is there, which is known as the Doppler frequency, and this Doppler frequency is actually proportional to Vt, the radial velocity of the either one, transmitter or receiver. So here what happened, suppose the object is moving, suppose it is a flying bird or a flying aircraft, then what will happen, that either this flying bird is approaching towards your transmitter direction, or it is flying away from your transmitter direction. So based on its direction of the movement, that whether it is coming to your transmitter location or it is coming away, going away from your transmitter location, there will be changes on the frequency, which we know or which we denote as the Doppler frequency. And you know this Doppler frequency is purely proportional to the radial velocity of this object. Okay, moving object, because your transmitter is not moving, transmitter is fixed in your in its position. The moving is the bird itself or the aircraft itself. So because of this Vt, that is the radial velocity component of this one, this flying object or this flying bird. So based on this one, we are able to find one, that if we are able to analyze the Doppler frequency, amount of the Doppler frequency, we will be able to find the existence or the nature of the object, whether it is a moving. Two kinds of conclusion will be there, that whether the object is moving or not. When the object is moving, then we have to find that what is its direction of movement, that whether it is coming, approaching towards you, or it is going away from you. That things, that is one information. Third information is what is the velocity or the acceleration of the object, because that information is also needed. When an aircraft is coming or it is entering to your area or your destinations, then obviously we have to identify that at what velocity it is approaching to you or at what velocity it is moving away from you. So that component or its acceleration, that also we are able to find out. So these are the normal, the parameters usually what we consider or what we obtain from the radar operations or the kind of things. So it has a lots of operations starting from the your defense to the civil operation for the air traffic control, even for the road traffic control. Even sometimes it is used for the study of the movement of the balls also. Sometimes very small kind of radars, that is like watch type of devices, that is attached to the ball to study the movement of the ball for the different matches or the for the different kind of things, or to train the training. Okay, so lots of applications. Even the applications is for the uh, for the weather broadcast or these kind of things. So lots of applications are there. Now just we have to consider this in terms of the schematic diagrams or the kind of things. So the basic is like this. Just if we plot it in terms of a very simple schematic, then the thing is, this is your radar transmitter, suppose, and correspondingly the receiver is there. I am drawing the transmitter and this receiver separately because in the transmitter usually we handle the megawatt of power, but in the receiver the power level is 10 to the power minus 12 or 10 to the minus 14, based on the different reflection coefficient or the kind of things. But both of them are operated with respect to a single antenna with the help of the duplexer. Later we will also consider the kind of duplexer what is used for the radar. So with a single antenna, sometimes it is used for the transmitter and the same antenna is used for the receiver also. So the energy is transmitted. Obviously the energy is transmitted in form of pulse, but which is modulated over a sinusoidal carrier. So it is the RF pulses modulated over a sinusoidal carrier. So the sinusoidal carrier inherently, and the profile is in terms of this kind of pulsating. So the pulse of this, so this is your nature of the transmitted energy that is sent towards the background. Okay. Suppose this is the background or this is the expected range. I will also consider how do we calculate the equation of the range. So this is your expected range. Suppose you want that ranging informations from this 10 kilometer. Okay. This one, suppose an aircraft is there which is entering into your background. Okay. Then what will happen? Whatever the fixed components which are present at this 10-kilometer background, you are carrying the echo from this. Okay. So suppose these are the form of the echo energy. Echo means the reflected component, echo signal. So these are the forms of echo. So when a flying aircraft will entering into your 10-kilometer background, then what will happen? Because of this entered portion or this nose of this aircraft, there will be a generated reflections. That means how it is interacting with the body of this entering one. Based on that things, whether a propeller is there or what are the kinds of formations are there, we will get a kind of interaction with this aircraft body, and a kind of eco energy will be generated along with your clutter. So this echo which are generated from here, it has two components. One is the fixed background feature, second is this one. So towards the when it will traverse towards this one and will captured by the receiver antenna and will be processed as the receiver, then what will happen there? On the based on the nature of the database what you are maintaining, you know that what are the kind of echo or what are the kind of basic amount of echo that can be generated without this aircraft. Okay, so just if we compare these things and follow this graph, then we might have an exceeding of the nature exceeding of the energy level or the power level, which is exceeding your threshold. So that will indicate that some extra interaction is happening there. And then we have to identify that what kind of interaction, whether the interaction with the human body or it is interaction with some metallic structure or some particular color. Sometimes this may happen. So you have heard this kind of problem, that although some aircraft is entering, but radar becomes blind about this entering aircraft. So that means they are using a particular type of coating over this aircraft material whose reflection coefficient, those kind of material is known as the metamaterial, where the reflection coefficient of those material is very less. So the total radar system sometimes becomes blind. Although some aircraft is entering into the picture, it is coming, it is approaching towards this with some velocity, all these things are there, but your nature of interception is so poor that within the echo signals, we are unable to process this amount of interactions or this amount of identifications. Okay, so that have different types of technology, so that we can also able to find out those meta material reflection coefficient also. Just here right now we are not going into those complexities. We will discuss the simple forms, what are there, or how the radar operates, like this one. Okay, so these are the gross informations or gross schematic. So now let us find the equation about the range. So what is the basic equation of the range? Basic equation of the range is the wave is transmitted from this transmitter location. It is approaching towards the background. There is an interception, and again it is coming back to you. So there is a two-way travel time. That means travel time for going and travel time for returning back. So this is known as the two-way travel time. So if the two-way travel time, that is this one and this one, this total time is tr, and you know the velocity of the RF in free space, that is c, then and it happens for two-way. So if I divide it by 2, the things what we will get, that is the range. Okay, so range equation is very simple. R is equal to c into tr by 2. That means whatever the velocity, if we multiply it with the two-way travel time divided by 2, we can get the usual range or the amount of range for the radar. And as it is a long distance detecting device, so usually the range is measured in terms of kilometer or nautical mile. The TR, that is measured in microsecond. So there is a very close relationship in between this. If it is in kilometer, then it can be expressed as 0.15 microsecond. If it is in nautical mile, then the conversion scale is 0.081 microsecond. Nautical mile is expressed in terms of NMI. Okay. So now a question is there, that how do we identify the unambiguous ranging? Why this happens? Suppose the entering aircraft for between operation between these two pulses, because your uh, energies are transmitted in pulsated form. So already I have introduced a terminology here, that is known as the pulse repetition frequency. That means that what repetition gap this pulsating is happening. So suppose this happens, that the existence of this intruder, this is in such a positions that we are getting the echo, received echo, not in a proper gap. That means what we are expecting, suppose this energy is transmitted. When this energy is transmitted, it will take a time to go here and it will take a time to come back here. That time we are considering as TR. Okay, suppose with the presence of the TR, we are getting some extra echoes. That means we are expecting that we will receive a echo for this transmitted pulse. Again, we will receive the echo for this transmitted pulse, according to which we have considered the gap between these two pulses. Okay, but around with this, we are receiving the more number of echoes. Then there is a doubt. Okay, why this doubt is there? That whether the second or third time echo what we are receiving, in both the cases between these two pulse positions, that is for any long distance or any intermediate distance. That means whether it is a long distance echo for the first pulse itself. Are you getting the things? Suppose for the first pulse we will receive a echo. For the second pulse we will receive a echo at a very regular manner. So that is a very regular thing. But in practical, what happens? Sometimes it may happen that in between these expected two echoes, we are receiving more number of echoes, multiple time of echoes we are receiving. Then obviously you will be guided by some doubt that why these echoes are generated. My gap of receiving is at least should be this round time after this round time requirement or this one. So why we are getting this multiple time echoes? Whether that is any approaching object is already there in between this long distance and this, or it is beyond this distance. That means after getting the normal echo or the regular echo for this first pulse, we are getting an echo from a distance beyond this 10 kilometer for this first pulse itself. It may happen that the energy of the wave is sufficient energy. So we are getting an echo from 12-kilometer distance because of this first pulse. So that will be in between this first and second. That is a multiple around echo. So multiple around echo means except the expected pulse positions, we are getting more number of echoes. Then obviously we have to be doubtless that where is the object or what is the unambiguous ranging, that actually from what distance we are expecting the echoes or the kind of things. Okay, so the range beyond which target appears at second time around echoes is known as the maximum unambiguous ranging. So what will be the formula for the maximum unambiguous ranging? So that is actually considered by this C into, instead of TR, there we will consider C into TP. That means what is your repetition period between the pulsating time. That is the gap time between this and this. This is your TP. Okay. So this CTP by 2, or we can write it is in terms of frequency C by 2 FP. That is inverse of this. That is known as the unambiguous ranging of this. Okay. So although we may expect the multiple times of echoes or the second time echo, third time echo, but we have to sort out the entire things instead of TR, we will consider it in terms of the TP. Because if we calculate it is in terms of TR, then we are not able to segregate that echo is for the second pulse or that echo is for the first pulse. Because this may happen for long distance beyond your range for the first pulse itself, or it may happen a very nearer object which is getting an interceptions for the second pulse or the third pulse. So we have to exclude all those doubts. So those doubts are excluded by this from these equations with the substitution of the TP. So if you are substituted this TR with respect to TP, so now doubt is there. Always it is with respect to the unambiguous rangings or the fixed distance. Okay. So as we have already know that usually the, if I consider TP, usually that TP is considered in terms of millisecond or in terms of kind of that things. PT if is the peak power of the things, then the average power, that also we can find out, which is an informations for the radar operations. So that thing is PT tau by TP. So tau is the durations of the pulse. So it can be written as PT tau 1 by TP means FP. So average power of the repetitive pulse train or the waveform, that can be considered by this equation, that is P average is equal to PT into tau by TP or PT tau FP. Okay. So from here we can also find the duty cycle of the waveform. So what is the duty cycle of the waveform? Anyone?
Baba,
What do you mean by the duty cycle? Ratio of the ratio of the total time. Huh. The latter is ratio. Yes, yes. So what is the I mean the duty cycle? Tau is the time for this one, and what is the total time it can radiate? The total time it can radiate is TP itself. So duty cycle is equal to tau by TP. Okay, or it can be written as tau into FP. So these are needed for the MCQ type of questions to find those things. So this is your case of the average powers or the kind of things. So that may we can obtain with this graph also. So suppose this is a positions of the transmitted pulse. This is an another positions of the transmitted pulse. Suppose these are the positions of the echo. Okay. So this is your time scale. This is your power scale. So peak power is, suppose PT is equal to in terms of 1 megawatt. That is the pulse peak power. From here up to this, suppose this is your TP. This one is 1 millisecond TP. This one, that is the kind of durations of this. It may be for this also. It is 1 microsecond. Here also it is 1 microsecond. This is echo. Say 10 to the power minus 12 watt. This is the amount of echo. So what will be your duty cycle? Your duty cycle is how much? Tau by TP. So this is equal to millisecond. This is in microsecond. Okay. So 0.001. Clear? So that is the schematic relationship between this, all this one. Now we have to write the radar range equations. So let us start from freeze equations. Anyone trying to say anything? So let us start from freeze equation, because the fundamental of freeze equation is, if some remote transmitter is there, then whatever the flux density available to a long distance from that transmitter, that actually we can obtain with the help of freeze equations. Not only this, if we place some aperture into the flux density, that amount of received power, that also we can obtain. So with the help of the freeze equation, if some remote transmitter is there, suppose it is radiating electromagnetic power towards these directions, then at a certain distance, what will be the flux density? F, that we can obtain with the help of freeze equation. And what is the equation outcome on the equations? Flux density F is equal to PT G by 4 pi r square. R is the distance involved in between the transmitter location and where we are measuring the flux density. Where we are measuring, it is up to the user concern that where it is measuring. G is the transmitting antenna. Is anyone?
आ गए हम कहाँ ये मैं इधर बदल दो
दूसरी तरफ
হ্যাঁ ম্যাম।
और लोग के बात कर रहा हूँ again here, that is at the point of the transmitter, we will consider the amount of the reflected echo. So that is our objective. So here freeze relation is getting modified by some different way. What is the types of the modification? Types of the modification is like this: re-radiated power. Who is the source of the re-radiated power? The member who are present in the background. So what happens? This transmitter is transmitting some power towards this location. Here the power is incident by the background. So there is a kind of interactions, or there is a kind of interceptions with the background materials or the background object. So that things is again reflecting back towards your radar receivers. Okay. So this re-radiated power means after interceptions, what is the amount of power that is radiated towards these locations or towards the transmitter. So radiated power means transmitted from transmitter. Re-radiated power means power which is radiated towards the transmitter from the background itself. So what is the amount of this? Suppose the coefficient of these things, or the area across which this happens, which is known as the scattering cross section, that is sigma. So sigma by 4 pi r square. That is the amount of the re-radiations. And the incident was this PTG by 4 pi r square. So look to the equations. This is incident flux density, PTG by 4 pi r square. This is get interactions with your background. Suppose the total scattering cross section is amount of sigma. This is known as scattering cross section. Suppose here is some micro area is there, some area is there. So the reaction happens with respect to that area. That is known as the scattering cross sections. And it is again traversing our distance. So it is creating a density that is by sigma by 4 pi r square. So re-radiated power density is like this. So what is the amount of received power here, or so that let us go to the next page. That is equal to, if I write this is PR, then PR is equal to how much? PTG by 4 pi r square. This is the amount of incident. Let us write it in broken form. so that you can get easy understanding. Sigma by 4 pi r square, this factor is responsible because of the re-radiation. So let us indicate this is as the re-radiation. Re-radiation factor, this is the incident. Then it is multiplied, if it is multiplied by area, that is known as the power, because except AE, the dimension of this is power per unit area. If I multiply with area, then the dimension will be power. So this is the whole expression of this entire things. Okay. So if I write it is in very gross, then this is equal to PTG sigma AE divided by 4 pi r square whole square. So that is actually known as the radar power equations. And if we consider that this PR is the receipt power, isn't it? This PR is the receipt power by radar. And so that means this is the amount of the echo what the radar is receiving. So if we consider, and if I have a look to this form, just here look at the level of the power. Here it is in terms of 1 megawatt, but when we are receiving this, it is in the order of 10 to the power minus 12 watt or 10 to the power minus 13 watt. So a huge difference is there. Okay. So this can be written as minimum signal, minimum detectable signal, because if it is, this is the signal power what the receiver is receiving, and it is based on the availability of the minimum, because if it is not above the threshold, then never it will indicate the existence of anything. Or sometimes it may happen that the thing is because of the noise itself or the movement of the clutter, and we are getting the very frequent exceeding of the threshold level. So there is a lots of justifications are there, that whether it is purely for the object, any appearing object, or it is for the because disturbance of the background itself. So if we term this minimum signal power with the notation S minimum, then the range equations that can be written as this is equal to, let us take a side change of these things, that is this R and this PR. So what we'll have, we have PTG AE sigma divided by 4 pi whole square S minimum whole to the power 1 by 4. Okay, so this is known as the range equations. So let us indicate with some reference. And you know there is a very popular equations of the antenna aperture and the gain, and you know that equation is G is equal to 4 pi AE by lambda square, isn't it? So if we use these equations, even the equation is in more accurate form. AE means effective aperture, so efficiency physical measurement divided by lambda square. So if we replace this equation into the equation 1 or the kind of things, then we get this to form R max is equal to PT. Here we are replacing A with the help of G. So A means AE is equal to how much? AE is equal to G lambda square by 4 pi. So if we use this into the range equations, then what is the value? The value is PT G square, this lambda square into sigma whole divided by 4 pi whole square is minimum whole to the power 1 by 4. This is the form. If we replace this G with the help of A, because this G, both the G and A are happening with respect to the same. Why? Come to the picture. Because the transmissions of the energy or the receiving of the energy, both are happening with the respect of the same antenna. So just if we replace the capital G factor, this capital G factor with the A factor, that means the transmission G factor with the A factor, as this A, same antenna is doing the performance of the A and G. So either we are replacing the both the A form from the equations or the G form. So in the second case, if we replace the G form, that means both the transmission G and the receiving aperture in terms of the A, then let us see what the equations. PT A square sigma whole divided by 4 pi whole square lambda square is minimum. Actually, there will be a, you are not following properly. This 4 pi
Ma'am,
square is same, it will be
R
4 pi
max
cube, isn't it?
4 by cube, yes,
This
ma'am.
will be 4 pi cube. And here it, this 4 pi square will not be there because the relation is what? You are replacing G with 4 pi A by lambda square. So 1 4 pi in the numerator. So square part will be cancelled. It will be only 4 pi. So this is the form is 1 by 4. Now look at a very mysterious factor that there is no existence of lambda in the equation of the range. Here just if we see the proportional factor is lambda to the power half. Here just if we see it is lambda to the power minus half, isn't it? Just here if we see this is proportional factor is lambda to the power half, because this is 1/4, this is 2, so 1 and 4 half. Here it is in the denominator, so proportional factor is lambda to the power minus half. So actually this difference is happening because on the interpretations how we are drawing, isn't it? If the interpretation is made with respect to the constant aperture or the constant lambda, then the difference is, then the difference, kind of difference what we are getting here, that the things. Okay, because here what is the thing? The gain is constant and here the effective aperture is constant. So because of these things, we are getting the different, I mean, the proportionality factor with the lambda. So just let us conclude the class with the help of a very normal schematic block diagram, because so many things we have considered. So just if we have a look over the total electronic systems, what our radar have, then how it does it look like. So this is the simple thing. This is your waveform generator. That actually drives a power amplifier, because the power level usually used in terms of megawatt power amplifier. And you need modulations also, because this will generate a sinusoidal kind of pulse, and for this you need a modulation. So this power amplifier is connected to a modulator, which is known as pulse modulator. So ultimately, when we look to the output of this whole section, we get the kind of waveform is a gated sinusoidal carrier like this. In a RF pulse profile or in a pulse profile, the RF carriers are appearing like this. Then it will drive a duplexer. The role of the duplexer is to produce the open circuit and kind of short circuit condition. Just the kind of things or device you have studied in microwave, the directional coupler, based on the power present in the input port, it is able to drive the power into the 3 dB loss or the different kind of power port like this. So there is a duplexer. So role of the duplexer is to routing the things towards the antenna, either from transmitter side. When the power will come from transmitter side, then it will create open circuit with respect to the receiver, because receiver usually handles the power in a 10 to the power minus 12, minus 9 in this level. Here it is handle the power in 10 to the power 6 watt or beyond that. So because of that things, the duplexer is there. That duplexer will feed it to the receiving antenna. From the same duplexer, the kind of reception is there. So this is the transmitted pulse, this is the received one or the echo. So usually for the receiver circuit, the first block is the low noise amplifier, which is a very essential block for any kind of receiver, as you know, just to boost up the signal level. So RF pulse will be obtained, boost up RF pulse will be obtained from here. That may be in change in frequency, that may not be change in frequency. Suppose if some Doppler shift is there, then it will be in some different frequency. So an extra circuitry we have to arrange there to find out the amount of the Doppler shift. But here, as we are considering a very simple schematic block diagram of the radar, we are not imposing any kind of condition, any critical situation. So usually the RF echo pulse that is received by the low noise amplifier, and then it is going to a mixer circuit. Mixer circuit is with respect to some local oscillator. So this mixer will consider two frequency, one is plus, another is minus. Obviously we choose the minus one. So as it is an intermediate frequency, so this stage is known as the IF. IF amplifier. After this, there is a match filter. You have heard about the match filter, because the role of the match filter is, for the digital system, the role of the match filter is to boost up the signal quality with respect to the noise, not the shape. Never the match filter correct the shape, always is boost up the numerator component. Just if you can remember or if you can recall your condition of the match filter. So after the match filter, there is another detector which is known as the second detector. So the kind of demodulations, last stage demodulation that happens here. Actually, when we do the radar operations, we never do the demodulation with a single step. We do the demodulation in two steps. So one mixer operation is there, after which it is known as the IF stage. After that, the last stage detection is there. So this last stage detection or this last stage detector is actually a demodulator circuit. It may be an amplitude detector, it may be a phase detector. If we follow this kind of things, that whereby trace of the amplitudes, we are trying to identify the nature, range, or the kind of locations. So there we use that detector, second detector, as the amplitude detector. But if we find the other informations, I mean, just if we look at the type of the conclusions, another conclusion is location. That means if we want to find out the elevation, angles, that at what angle the thing is happening, not only the distance. So there the kind of information or the kind of detector what we use, that is a phase detector. Okay, so based on the type of information, that you either you are trying to find out the range only, or you are trying to find out the angle also. So if it is angle also, then this second detector will be replaced by a phase detector. So that is the difference. Second detector may be an amplitude detector or maybe a phase detector based on the type of the parameter what you are trying to, detect. So after this, there will be a video amplifier, broad amplifier, and this whole thing is known as the envelope detector. What I already told you, envelope detector. Then it will go to the threshold. That means that old level, that whether to compare it, that this excursion of the signal is only for the noise or for the signal plus noise, or what is the things appearing there. So when it is going to that threshold, that means the this comparing device, and it is going to the display. So different kinds of displays are there. CRT may be used, that is what we use in the scale of the CRO, or plant position indicator, PPI, where they appear in form of polars, that is in form of angles. So from there also, just by considering this one, we can get the conclusions that what is the appearing range, what is the appearing angle, or the more other derived things, velocity, accelerations, etc., etc. Okay. So this is the very fundamental operations for the range equations, or the kind of operations with which we can have an very simple pictures. In the next class, we will consider the kind of detections and the phenomena which are associated with the detections. That how do we exclude the actual informations from the other disturbances or from the other variations of the clutters. Okay. So this is the thing. Any questions or doubt? Any file, you can feel free.
Ma'am, in the above equation, what is AE? Aperture
Okay,
efficiency
okay,
or area of detecting?
okay. Let me come. Follow this one. This one is incident flux density. That means incident, this first golla, that is power radiated per unit area for the incident wave. Clear? This one, this first golla. This second
Yes,
golla,
ma'am.
that is the re-radiated. That means after having reaction with the background, what the background flux density is appearing. So this sigma is the amount of the background scattering cross sections. Again, the distance involvement of r is there. So 4 pi r square is there. So when we take this product of two golla, it is, we are getting that how much flux density is available at your receiver location. So this two golla is giving us amount of flux density. That means amount of power received per unit area. If I need to convert it in terms of power, we have to multiply it with some aperture of the area, isn't it?
Okay, ma'am.
So how the aperture we are getting? With the antenna dimensions. Because just think about you are immersed into some radiations, but how much energy your device is capturing based on your antenna size. That means your device is using the kind of antenna, based on that size you are capturing the power. Rest one is just getting into spoil. So this AE is the amount of the capture area of the receiving antenna. Now the thing is, same antenna is acting as a transmitting antenna and a receiving antenna. So in the latter case, either we have replaced this G in terms of AE or this AE in terms of G, and we are driven to these equations. Am I clear?
Yes, ma'am.
Okay. So small, very MCQ type of question are there. Here,
Ma'am,
best bowler.
why do you use the second detector?
Actually, what I told you, that the range of operation, the operating frequency of the radar is some megahertz to 240 gigahertz, like this range. This is the carrier frequency of the radar operation. So usually for this high frequency, that means in the millimeter wave or in the sub-millimeter ranges, we do not do the demodulation in a single step. because single step demodulation, just if we consider the demodulation with respect to a single one, that is with respect to the first one, we will lose the quantity of we will lose the informations. That never consider. So we do the demodulation in two stages. Just follow here. Here, just with the help of this local oscillator, we have stepped down the RF frequency. Suppose here the frequency of operation is in 100 gigahertz. So 100 gigahertz means 10 to the power 9, isn't it? We never do this scale down in a single step because of the loss of the informations, chances of loss of the information. So a kind of scale down here we have considered with the help of the mixer circuit and the local oscillator, and it's an intermediate frequency. It is neither in the baseband domain, not in the carrier domain. Then we have used this second stage or the last stage demodulation. Now what I have told you, this last stage demodulator may be an amplitude demodulator, or it may be a phase demodulator or the frequency demodulator, based on the kind of tracking what you want. If we use the Doppler frequency, that means when the radar is using to identify some moving object, so there your first concern is that what is the Doppler shift, because this Doppler shift is proportional to Vt. That means at what speed aircraft is entering into your domain. So their speed factor, identification of the speed is a matter. So there this amplitude detector will be replaced with the phase detector. Okay, but if it is only for the ranging operation, just here in this schematic diagram, we are using only to extract the range information. We are not bothering that whether the target is moving or target is a still target. Just we try to identify that any object is there or not. So there only a simple amplitude detector is enough to identify the informations or to extract the informations. So here the second detector will be simply a amplitude detector. Okay, and the reason is usually from this millimeter range demodulation, we never use the kind of single stage. In the other paper where we are considering the satellite transponder, there also the frequency of operation in gigahertz. So there also usually we do the kind of demodulations or we do the scale change in two steps. Later when I will show you the block diagram of the transponder, there you can see the transponder is operated in two steps. We do the scale change in two steps. The reason is for the very high frequency to avoid the losses. Usually we do it the multiple stages. Okay, so that is why first step demodulation is here, not a demodulation, a scale down is here, then we do the demodulation. What kind of demodulation you will use, that based on what kind of conclusion you want, whether only for distance or distance and angle or distance, angle and the velocity also. Depending on these things, your systems will be much more, or your systems will be critical as per. Okay. Any other?
Yes, ma'am.
Any
ম্যাম
other question?
ডুপ্লেক্সারের কাজটা কি ছিল?
ডুপ্লেক্সারের কাজটা হচ্ছে রাউটিং করা। আমি ডুপ্লেক্সারটা তোমাদের পর পড়িয়ে দেবো র্যাডারে। মানে যখন আমি ধরো এখান থেকে পাওয়ার লেভেলটাকে ও এইদিকে কানেক্ট করবে, এর লেভেল হচ্ছে 10 to the power 6 ওয়াট, আর এর যদি পাওয়ার লেভেল দেখো, ফ্রিকোয়েন্সি অফ অপারেশন না, পাওয়ার লেভেল দেখো, এর পাওয়ার লেভেল হচ্ছে 10 to the power -10 -12 এরকম। তাহলে এ কি রেঞ্জে কাজ করছে? এ তো যদি মেগাওয়াট কোনো রকমের লিকেজ হয়ে যায় এদিকে, পুরো সার্কিটটা বার্ন করে দেবে। তার জন্য ডুপ্লেক্সারের কাজ হচ্ছে যখন এই দিক থেকে পাওয়ার ইনপুট থাকবে, তোমরা যেমন 3dB কাপলার পড়েছিলে মনে নেই, রাউটিং করে ইনপুট পাওয়ারটাকে রাউটিং করে আইদার এদিক দিয়ে বা এদিক দিয়ে। তো ঠিক সেরকম যে যখন এই এন্ডে পাওয়ার থাকে তখন এই দিকটাকে ও ওপেন সার্কিট করে দেয়, তাহলে পাওয়ারটা শুধু এই লাইন বরাবর বেরিয়ে যাবে। যখন এই এন্ড থেকে পাওয়ার থাকে তখন শর্ট সার্কিটটা এদিকে করে, এদিকে কিছু পাওয়ার চলে গেলেও কোনো প্রবলেম হবে না, কারণ লিকেজ এদিকে গেলেও সেই লিকেজটা এখানে 10 to the power ওয়াট লেভেলে, মেগাওয়াট লেভেলে ফাংশন করে। সো এখানে যদি 10 to the power -10 বা 14 এদিকে লিকেজও হয়, সেটা এদিকে কিছু প্রবলেম করবে না, বাট ম্যাক্সিমামটা এইদিকে ড্রাইভ করতে হবে। সেই কাজটা ডুপ্লেক্সার করে। এটা সলিড স্টেট ডিভাইস দিয়েও করে, আবার অনেক সময়তে সিআর টিউব থাকে, সিআর টিউব মানে হাই পাওয়ার থাকলে এখানটা ফিউজ করে দেয়, অথবা ফিউজ করবে না। যদি ফিউজ করে দেয় তাহলে পাওয়ারটা এইদিকে যাবে, যদি ফিউজ না করে তাহলে এদিকটা পুরোটা ব্লক থাকবে, ওটা অন্য পাত দিয়ে লিক হয়ে যাবে। সেই কাজটাই ডুপ্লেক্সার করে।
ম্যাম এটা কি একদম ওই যেভাবে 3dB কাপলার যেভাবে কাজ করে সেভাবেই করে, মানে
সেম
যেমন ওই
টাইপের
মানে আউটপুট যেমন ইনপুটটাকে দুটো আলাদা আলাদা ভাগ করে দেয় আউটপুটে?
একদমই তাই, একদমই তাই। সিডিপি কাপলার দিয়েও করা যায়, কিন্তু সিডিপি কাপলার দিয়ে অনেক সময় পুরো সেফটি আসে না। তোমরা মাইক্রোওয়েভ সার্কুলেটর বা আইসোলেটর যেগুলো পড়েছো সেগুলোর কাজই তো তাই। এটা তো মাইক্রোওয়েভ রেঞ্জ, মাইক্রোওয়েভ রেঞ্জে পাওয়ারটাকে প্রপার পোর্ট দিয়ে ড্রাইভ করে দেওয়া। তো ওইটার যা ফাংশন এটারও সেম কাইন্ড ফাংশন।
ঠিক আছে।
ওকে, আর কিছু কোয়েশ্চেন? যদি না থাকে তাহলে আজকে এরপর আর আমি প্রসিড করবো না। নেক্সট দিন মানে কালকে নিয়ে নেবো, তাহলে কয়েকদিন এগোলে এটা একটু এগিয়ে যাবে খানিকটা। ঠিক আছে, ওকে,
Okay, ma'am.
লিভ দ্য ক্লাস।
থ্যাংক ইউ ম্যাম।
Thank you,
Thank
ma'am.
you.